2002. Papineni and co-authors at IBM ship BLEU. Bilingual Evaluation Understudy. A single number that scores how close a machine translation is to a reference human translation. The whole field jumped on it. For 20 years, if you built a translation system, you reported BLEU. Papers were accepted or rejected on BLEU deltas. And for 20 years, the field also knew BLEU disagreed with human judgment, constantly, sometimes badly. Welcome back to Lecture 10. Today, evaluation. How do you actually know if a language model is any good? We will cover BLEU as a cautionary tale, ROUGE for summarization, BERTScore for semantic similarity, human evaluation for the ground truth, MMLU for knowledge, and the leaderboard trap that has burned the field at least twice. V5 covered hallucination. The model produces fluent, confident, factually wrong text, which brings us to the natural next question. How do you measure model quality when the outputs are open-ended text? You cannot just compute accuracy on multiple choice. You cannot easily check if a paragraph is right. Evaluation of generation is one of the hardest technical problems in the whole field, and the metrics we use routinely lie to us. Today's puzzle. If every automated metric we build is only a proxy for what humans actually care about, why do we use them at all? Answer: because human evaluation is slow, expensive, and inconsistent. Automated metrics are fast, cheap, and repeatable. So the field uses automated proxies to iterate and periodic human studies to check the proxies. When the proxy stops correlating with humans, the field has to change proxies, or it optimizes toward a hollow number. Today's 3 beats. First, surface overlap metrics. BLEU 2002 and ROUGE 2004. How they work, why they were popular, and why they mislead. Second, semantic and knowledge metrics. BERTScore 2020 for meaning, MMLU 2020 for facts, human eval as the ground truth. Third, the leaderboard trap. How Goodhart's Law killed BLEU MT and how it is currently threatening LLM benchmarks. Beat 1. BLEU. The trick is NGRAM overlap. Count how many 1-word, 2-word, 3-word, and 4-word chunks the candidate translation shares with the reference translation. Combine them into a single geometric mean. Add a brevity penalty, so the model cannot cheat by producing very short outputs. That is it. A single number between 0 and 100 that shows how much the machine's word choices overlapped with the humans. BLEU has a fatal flaw. It only rewards using the same words as the reference. A translation that says the same thing in different words scores badly. A translation that has the right words but in nonsense order scores well. Callison-Burch 2006 documented this in painful detail. BLEU rankings frequently disagreed with human rankings, especially between systems using different architectures. And when Neural MT arrived after 2014, BLEU sometimes ranked the worst system higher, because the older phrase-based systems copied reference n-grams more literally. Chin-Yu Lin's ROUGE metric, 2004, extended the idea to summarization. Same n-gram overlap principle, but you have multiple reference summaries and you also measure recall. How much of the reference your candidate covered? ROUGE 1 counts unigrams, ROUGE 2 counts bigrams, ROUGL counts the longest common subsequence. ROUGE became for summarization what BLEU was for MT, and it inherits the same fatal flaw: reward, same words, punish paraphrase. Beat 2. BERTScore. Zhang and co-authors, ICLR, 2020. The idea: instead of overlapping surface tokens, overlap contextual embeddings. Encode the candidate and the reference with BERT. For every token in the candidate, find its most similar token in the reference by cosine similarity. Average those similarities. Compute a precision, recall, and phone. Now paraphrase gets rewarded because feline and cat land close in BERT space. BERTScore correlates with human judgment, much better than BLEU on most tasks. For LLM knowledge, the field turned to MMLU, Massive Multitask Language Understanding. Hendrycks and co-authors, ICLR 2020, 57 subjects, high school math, law, medicine, computer science, moral philosophy, and more. 15,000 multiple choice questions. If you can answer them, you know things. GPT-3 scored around 43% in 2020. GPT-4 hits about 86%. Human experts get about 90%. MMLU became the de facto knowledge benchmark for every LLM release. And then there is human evaluation, which sounds simple and is not. You show human raters two outputs side by side. Ask which is better. Aggregate a Bradley-Terry ranking. This is what Chatbot Arena does. Thousands of pairwise votes turned into an ELO-style leaderboard. It is the closest thing the field has to ground truth for modern chat models. But even human eval has known problems. Length bias. Humans prefer longer answers. Style bias. Humans prefer confident, well-formatted responses even when they are wrong. Human eval is the best we have. It is not neutral. Beat 3. The leaderboard trap. Goodhart's Law. When a measure becomes a target, it stops being a good measure. It killed BLEU, ROUGE, and MT systems that maximized BLEU produced translations that scored well and read badly, and it is threatening every LLM benchmark right now. When a benchmark like MMLU becomes the metric everyone races to top, labs start training on data that resembles the benchmark, sometimes accidentally, sometimes not, and the score inflates while actual capability does not. The concrete example that is already happening: MMLU questions have been quietly leaking into web-scraped pre-training data. Test set contamination. Newer benchmarks like GPQA and MMLU PRO were built precisely to be harder to memorize. Helm at Stanford tries to test many capabilities simultaneously to make Goodharting harder. Chatbot Arena rotates prompts to prevent optimization. Every one of these is a patch on a fundamental problem. As soon as an evaluation is public and popular, it starts to decay. So, the honest practitioner's stance: never trust a single number. Report multiple metrics: a surface metric like BLEU or ROUGE for reproducibility, a semantic metric like BERTScore for meaning, a knowledge benchmark like MMLU where relevant, and human evaluation as the anchor. Watch for benchmark saturation. And when your model's number keeps going up but the actual usefulness plateaus, trust the users, not the leaderboard. That is how you avoid becoming the next BLEU cautionary tale. 3 takeaways before the quiz. 1. Surface overlap metrics. BLEU 2002 and ROUGE 2004. Reward same words and punish paraphrase. Callison-Burch 2006 documented BLEUs, disagreement with humans. Useful for reproducibility, not usable as the sole quality signal. 2. Semantic metrics like BERTScore 2020 fix the paraphrase problem. Knowledge benchmarks like MMLU 2020 measure facts. Human evaluation is the ground truth but has known length and style biases. 3. The leaderboard trap. Goodhart's Law. When a benchmark becomes the target, it stops measuring the thing. Always report multiple metrics, anchor with human eval, and trust users over leaderboards. Quiz 1. What was the fatal flaw of BLEU that Callison-Burch 2006 documented? A. It was too slow to compute. B. It rewards using the same words as the reference and punishes paraphrase. High BLEU can go with a bad translation, and it often disagreed with human rankings. C. It could only be computed on Chinese. Or D. It was patented and closed source. B. NGRAM overlap treats the feline reposed on the rug as a bad match for if the cat sat on the mat, even though it means the same thing. And a word salad translation with the right n-grams scores high. Callison-Burch 2006 was the classic warning that BLEU had already become a bad proxy. Quiz 2. How does BERTScore improve over BLEU? A. It uses a bigger NGRAM window. B. It scores by matching contextual BERT embeddings between candidate and reference tokens, so paraphrase is rewarded because feline lands close to cat in embedding space. C. It ignores the reference translation entirely. Or D. It measures fluency only, not adequacy. B. Semantic overlap instead of surface overlap. Encode both sentences with BERT. Cosine match tokens, compute precision, recall, phone. Correlates with human judgment much better than BLEU. Not perfect, much better. Quiz 3. What is the leaderboard trap in NLP evaluation? A. Hardware constraint on benchmarks. B. Goodhart's Law. Once a benchmark like MMLU becomes the target, labs optimize toward the benchmark rather than the underlying capability, so scores rise while real usefulness may not. C. A bug in the MMLU dataset. Or D. The requirement that leaderboards be private. B. The same failure mode that killed BLEU, DRV, and MT is currently threatening every LLM benchmark. Test set contamination, benchmark style fine-tuning, prompt engineering tricks. Newer benchmarks like GPQA, MMLU PRO, Helm, and Chatbot Arena are attempts to patch it. Public plus popular equals decaying. Back to the puzzle. The reason we use fast, cheap, imperfect proxies is that human eval does not scale. The reason we cannot only use them is that every proxy decays the moment it becomes the goal. The right stance, multiple metrics, human anchor, humility. Next video, RLHF and constitutional AI, how you actually align a raw LLM. Next time, RLHF, constitutional AI, and how ChatGPT actually learned manners. Cristiano 2017, Ouyang 2022, Instruct GPT. By 2022, Constitutional AI, the alignment problem in one video. Hit subscribe.